right, guys, so it's built and it is sturdy in there. It's not going anywhere. I put huge shaft magnets in, so there's only about a 1/4 inch distance between the outer edge of the inner magnet and the inner edge of the outer ring magnet. And I put glass. You can't really see it, but I put the glass disc up against there. I measured out these and printed them. It is in there for good. It's not going anywhere. Yeah. Let me get it set up and running. Stay tuned. Yeah, and if you guys remember, I have super north and super south because I don't have the poles facing out. I have them facing each other. So this is a super south. This is a super north, super south, super north. I wanted to see how that works. And I'm sure it's going to work just fine. But yeah, it's still producing poles that are facing out. It's just I'm not wasting any poles now, so there's no poles pointing in towards the shaft. Yeah, that came out really nice. This thing should work fantastically. Although I do notice that one is in a little further than that one, but I don't think that's going to make a difference. And this base worked out really good instead of that piece of garbage that I had set up. All right, let me get it set up. Stay tuned. So I tried to be lazy and hot glue this magnet plate, this one here, to here. And although it was looking really good, the magnets are too powerful. It eventually pulled itself away, which is not a big deal. I can fix that, but I'm going to have to not cheap out and use hot glue. I can use hot glue to tack it there, but I'm going to need to drill 4 little holes there to put some screws in. Yeah, I can't cheap out like that. This one is held in place with hot glue, this one right here. And it's okay, but not for something like this. Not at the speeds this thing's going to be going. So I got the old scraper out. And this is a cool scraper. It's got a dual end. Or it has a plastic razor blade for scraping stuff like that. Anyway, let me do this the right way. Stay tuned. All right, so I got these nice brass screws that I'm going to use to push through, to drill through here, all the way through into the back plate. I even got these really cool copper washers. The only thing is, drilling into 3D printed parts is tricky because it's not solid plastic. When you drill in, you could be drilling into a cavity. Even though I made the infill here pretty tight, it's still not a pretty picture. So what you can do is you drill a little bit, then you pump it full of like crazy glue or some regular glue. Let that settle, drill a little bit more, pump it full, or you can just take your chances and go all the way through. Yeah, it's a pain in the ass. So I'm going to have to give it a shot, though. Yeah, I'm going to have to give it a shot because there's no way I want to leave this set up like this with just hot glue. I thought it might work, but in the back of my head, I was saying, nah, this is a bad idea. You need some real anchorage. You need some real anchors in there, some bolts. And these are nice thin ones. I opted to get thin ones, and I have the washers. I probably should have gotten some bigger washers, but I think it'll be okay because, again, I've got a tight infill in here. So it shouldn't be too bad. I'm going to practice on the other pieces that I have, not these. These were spacers, but I have other ones that are just like this that are 5 millimeters thick. These are 5 millimeters. This is 3. And this is actually the copper infused PLA. I didn't use it on this side because I had already printed those out. All right, so let me practice it on another printed part to see how it comes out. Stay tuned. So the practice piece wasn't as bad as I thought it was going to be. You can, if I can get this closer and let it focus. Focus you. You can maybe see some of the infill in there. But this one was a, what was that? This was a, hold tight. Damn air compressor. This one was a 5/30. This hole was a 5/32. Oops, sorry. And as you can see, it's kind of loose. This one was the next size down, which was a 9/64. It's a little, oops, sorry, it's a little bit tighter. So I'm going to go with that one because I want a tighter fit. But yeah, it didn't come out too bad. But again, this was only going through one layer. I've got to go through 5 layers and then into the acrylic. I'm not worried about the acrylic. Well, actually I am, because once I go through the plastic and I extract all of the plastic material out, after I'm going to use the drill press, when I start drilling into the acrylic, it's going to want to also extract that melted plastic out, and it's going to want to try to come out through these holes. Maybe I should drill it. No, I don't want to drill it that way. Maybe I should, though. All right, we'll do a test on the first one and see how it comes out. Stay tuned. Actually, it turned out not to be too bad. It went through nice, and when I got to the acrylic, it didn't do what I thought it was going to do. I have to be careful, because I almost hit the side screw. So I have to be careful with that one. I got to bring it just a little bit lower, because that side screw comes out. Come on, focus, you piece of crap. Anyway, yeah, it came out pretty good. Let me get the rest of them. Stay tuned. So it's funny, when you build stuff, you only make a mistake one time, and then the next time you're doing it, you don't make the mistake. What's wrong with that picture? I didn't take into account the thickness of this. So the screws are literally right on top of this plexiglass. So I got to take these out, drill some relief holes so that I can actually get a nut on there. I'm not going to worry about it now because it's the top part that pulls away, not the bottom. But oh, that pisses me off. So this one I obviously did right. I drilled it higher. Ugh. Ugh. And actually, I'm probably going to take these out at some point and cut them off, because they're a little bit too long. They didn't have any 1 3/4. They only had 1.5 and then 2 inches. If I wanted 1 3/4, I'd have to get it online, and I do not like to wait. Not when I'm this close to first run. All right, stay tuned. Yeah, this is coming out good. I am so glad I did not glue this this side mount to the base. It was glued on a little bit from when I glued these guys together, temporarily, obviously. And yeah, because if I had to try to do this, so I printed this, what's called a hyper fast profile, and I didn't learn until after the first 2 prints that I had to increase the temperature big time, because the hyper fast is exactly what it is. It's hyper fast. I was able to print out 4 of these in the time it would normally take me to print out 1. But The trade-off is that the print is not too strong, but this can be fixed with a little bit of CA glue. That's not a big deal. But yeah, thank you, Chuck. Chuck from CHEP, Filament Friday, created these incredible profiles so that you can print 10 times faster. And at first he only released them to his patrons, which I am gladly a patron, but then he always releases it. He gave it to his patrons for us to test, but we all knew they were going to be great. But then he always releases it to the public, which is really great for him to do that. It takes a lot of time to build these profiles so that they're printing out okay. See, these were done in the hyper fast one, and there's no issues there. But I remember I did this one first, and it has a little bit of an issue, but not bad enough where it's going to ruin the part. Again, these are functional parts, so the hyper fast, he's got a fast profile for 0.12, 0.20, and 2.8, but he's got a hyper fast for, and it's 0.32, which is really weird, but it works freaking great. So Chuck, thank you, man. You've changed my printing game for my functional prints anyway. All right, stay tuned, guys. So just in case any of you guys were going to try to replicate a maglev, one of the biggest things you have to get right is how you place the ring magnet in relationship to the central shaft magnet that goes in there. So if the shaft, this guy here, I don't want to get it too close. If you put this to it, and that registers north, meaning this north pole is out, you have to put this in so that the south pole is out, but the center registers as north, and that's what you want, north against north, because as soon as you get to the other side, it then pulls it against the glass. The south pole will then pull the north pole against the glass. If you try to do it the other way, it's a nightmare. But yeah, so this is south facing out, but the center is north. And so that's how you have to figure it out. And you know, if you forget, trial and error will show you that you can't do it the other way. It's damn near impossible. So let me get these guys in here, and I'm going to have to glue these in. I don't want to, but I'm going to have to. And so I mark all my magnets with the north, so that north is going to be facing in, so that the south is facing out. But again, the center of the magnet produces a north, because the pole wraps around like this, right? And is going through the hole there. Anyway, just in case you were thinking about maybe setting up a little maglev, and the same thing goes for the maglevs that aren't supported all the way around, the one that just has the 3 magnets and you drop the rotor in there, it's the same deal. Stay tuned. Yeah, and you can see I put a little bit of the really fine CA glue on there, and it gets all down inside there and it bonds it instantly. All right, let me get these magnets put in place and let's get this thing running. Stay tuned. So that's better, a little bit more secure. And I don't see any chatter with that thing. It's really locked in there because I used much bigger magnets. Yeah, let's see if we can get it going here. Stay tuned. All right, so as gorgeous as this looks, remember I mentioned before that this one was like right on. It was right even like it's supposed to be. This one is too far in, way too far in. So it's hitting at high speeds. It hits the magnet. It hits this magnet. So I have to put another glass piece in there to pull it out a little bit. So let me see if I can get that done. Stay tuned. I think I got it fixed. I put a piece of mirror in there. I'm not happy with that because it's not very strong. I'd rather just get a piece of glass. Let me see how it works. Stay tuned. So amazingly, it self-starts, but it really rattles a lot, and I don't know why. I don't know if this is because this is not stationary. I have to kind of hold it like this. See, it self-starts. Oh, there we go. It's just because it's rattling on the glass, but it is flying. It is flying at 12.3 volts. Yeah, I don't even know what the RPM is. I don't want to let go of this. So I have to figure out a better way to secure this. I'm going to probably knock these leg things off and put another piece of plexiglass underneath there. But it's working great. It is working great. But I gotta... You know what I'm going to need to do? I'm going to need to build or 3D print a brace that goes over the top of this. Because, yeah, it's flexing. See it flexing like that? But it's flying, so it works really well. Let me see if I put that somewhere else. Yeah, I got to do something about the base, but it works good. It's flying. All right, let me turn it off. So a couple of things I'm going to have to work on. Getting rid of this flex. Let me also making sure that that's in there and getting a better backing instead of that mirror, that piece of mirror I have. Yeah, it's digging into that mirror. So I need to get another piece of glass for this side because this side's working great, but it's digging into that mirror. And I need to secure this base. Other than that, it's working great. All right, guys, thanks for watching.